We're starting session 24, and this is an interactive workshop that will be hosted by Prof. Karin Wolff, where she will showcase the use of LCT tools to bridge the gap between the engineering curriculum and workplace practices. Thank you, Dr. Wolff.
Okay, I'm going to.
Okay, now you're on the flat. Okay, so you can stay on this for a moment. Especially the team. And there's some people who might want them to start with, and this was my home. And these wonderful people that is now the professional.
Hi, Team CPUT. We seem to have lost the main audio.
There's no sound.
Yeah.
Still no sound.
Is that working? Can everyone hear? Can we have
Yes,
a thumbs
thank
up
you.
from someone?
Thank you.
Fantastic. Thank you, you guys. And that is a case in point of exactly what we're going to be addressing. We've just come from the fantastic presentation by Chris and Simon Winberg on their work in this whole smart space. And I think I just want to say to the CPUT team, the lead up today and the orchestration of what you have in all the sessions that we've had today, and we had sessions prior to actually coming online to you all, is a beautiful semantic wave. And in fact, it would be a beautiful code shifting around the semantic plane, quite frankly. So we can go over to the slides. Thank you, you guys. Right. So this is going to be an interactive session, and we've been running ours a little different technologically. So I can't see you on this beautiful big screen in front of me. I can only see my stuff. But I think it's going to be interactive in the sense that we've been talking about a lot of workplace practice orientated things in the health sciences, health professions you heard earlier, and now in the shift to engineering, and I'm going to be focusing more on engineering. But this is all going to be in the context of, okay, so how do we get there? How do we, and I actually changed the title as well to improving students' employability through work-facing learning. And we're going to look at how we scaffold towards that. But before I move on with these slides and say that, the context here is that at this very institution with Chris Winberg and what was then the Work Integrated Learning Research Unit, we had a number of projects, but international collaborative projects. And one of them funded by the Department of Higher Education and Training, ESCEP project. So the examples I'm going to be showcasing here today come from all those participants. And I'm sorry that I didn't acknowledge them on the screen with the little ESCEP logo. But this is work that's been done over a number of years. And some of these people are, in fact, online, Robbie Pott being one of them, I'm picking on you, who were part of that original project, looking at how do we bridge this gap. So we heard beautifully from Chris everything about this wonderful, smart fourth industrial revolution environment out there, and all these fantastic expectations that industry has of our graduates across the board, whether they be technicians, technologists, or engineers. And the problem here is that, we hear leadership talking about smart cities and these fourth industrial revolution skills and all of these things. But our own experience in COVID era teaching has highlighted just how complex that term is, the socio-technical that Chris was talking about earlier. You know, this landscape is incredibly complex. And what we know, particularly in the global south, the other thing that was highlighted is just how acutely aware we need to be of what we're calling the digital fluency challenges, okay? Now, I'm driving two things at the same time. Now, just to tell all of you, and this is not new to anybody, people have been talking about, well, the technical skills gap. If you just type technical skills gap onto the internet, and you'll come up with a host of references. Not only technical skills gap in terms of that whole digitization that Chris and Simon's paper is about, but a major call for meeting the soft skills. What are these things that we're calling soft skills? What is the stuff I think Cecilia referred to this morning as the fluffy stuff? But the reality is, you guys, this is nothing new. Oh, I'm pressing the wrong one. There we go. The 1930s, Chris so reminded me of the paper you just done on where workers were talking about how their jobs were threatened because they couldn't compete with the unbearable speed of the assembly line. Then 1955, shortage of technical manpower. I bet my bottom dollar, which I don't have, that if you go back to the first industrial revolution, this is the chorus. We've been singing this forever. The difference is, as Chris and Simon's study also pointed out, was that we could maybe argue that it's become exponentially more complex, and that because of the digital age, we're aware of so much more. But that means in that social space and the everything is connected space, everything is more complex. So what we're going to do today, very briefly, is we're going to look at 3 strategies here. 3 strategies using LCT tools of how do we get these students, whether they be in whatever sector, to the world of work in relation to what those workplace practices are. So it's a very practical applied session. I'm going to ask Liesel, wherever she is, yes, and everyone else to keep an eye on the time. I'm going to introduce 3 different kinds of strategies using a different legitimation code theory tool, and then show you 1 or 2 examples. And then we've got a number of ways in which you're going to contribute. And this, because there are so few of us in this environment, there are not that many, and I see there are only 1 or 2 or 3 maybe engineers online, I'd love to hear from the other non-technical professions if they can relate to this. So we're talking about theory practice bridging, preparing for employability. What are those workplace practices? So the first one needs no introduction. We all know this. This fundamental principle of effective learning is what we call cumulative learning in LCT, learning that builds on what has come before, learning that builds on those threshold concepts we were referring to earlier, and applying those, learning that effectively connects the why, what, and how. So this semantic wave is a very simple representation, but it's been the starting point for so many educational researchers, particularly those working in the professions. As we've seen now over the whole of yesterday and today, this is a very, very practical way to look at how students learn. Now, I've taken Kolb's learning cycle, and if we take that whole principle of experience, engage, think about, reflect, conceptualize, that whole cycle, and you add it so beautifully to the semantic wave, what I'd like you to imagine is building a trajectory over time that moves between concepts and contexts, between the abstract and the concrete, while actively doing something and being able to reflect on the process and building this process over time. Now, I'm fortunate to be in the home of a publication which came out over a decade ago, which was called the Work Integrated Learning Guide, or good best practices. And most of those authors I've actually seen today. And this was with Chris Winberg and her team. And now, the whole point of this original document was to highlight that there are different modes of what we call work integrated learning. And today, we use this term in a very conflated sense in the South African context, I have to tell you. But this guide was seminal in explaining and problematizing and giving good applied examples of different kinds of learning that can face the world of work. That was the whole point. Different kinds of learning that you can engage in at different stages so that we bridge this gap between theory and practice, basically. Okay, so now if we connect this to our lovely semantic wave that I already carved out there, and we take some of those modalities, what you'll see is that each of the kinds of learning that you can do that enable us to get to an employable graduate fulfills a different role and can be located in a different space on the plane. So work-directed theoretical learning may well be directed towards the world of work, but it is what it says. It's theoretical. Its aim is to anchor the theoretical concepts. Then we move down our semantic wave a little. Problem-based learning is also at a tighter focus on let's say a fundamental threshold concept or two in a very specific, let's say, bounded problem, very often with the application of a very specific kind of technique or method for something. Then we go and we see that project-based learning brings us closer to contextual realities or the more complex world itself. And these things take on, very different natures. Yes, here you can have working in a team or working in relation to the socio part of socio-technical. But project-based learning, if you look at the literature, is also is so vast. It depends on context, which is why it's more context specific in terms of how it's applied and how it's practiced. Now, if we move to the fourth example I'm using, please note that the guide had multiple examples in it, okay? I've just chosen 4, and I'm hoping that what you can see is that you can't just take one example of a work-facing experience and throw it at a student and think, right, they're ready for work. There needs to be an orchestrated, imagine that cumulative wave over a program. In fact, as an ethic across an institution even, or a faculty even. Now, the problem with workplace learning in our South African context is that our students have very, very different experiences of these. And it's one of the reasons that's caused a fundamental shift in our context, but I'm not going to talk about that. But I want to also highlight, I think it was earlier, Chris, I also think it was in your paper where you mentioned your top quadrant about the stronger epistemic relations being theory, theory, theory. There's been a misrecognition of how to cope with the complexity by many of our employers who think it's because they don't know stuff, so teach them more theory. This is far more complicated and complex than that. So let's look at that top example. One way, for example, of moving up and down that plane, but starting with work-directed theoretical learning. Here is a case study by Debbie Blaine, Professor Debbie Blaine from Stellenbosch, who was part of our ESCAPE project, a broader project, where they've built a whole series of work-facing case studies. So this is very similar to the radiography studies, very similar to, imagine that's looking at real tissue or a real tumor. Well, this is real fractures in materials, okay? So the students get this in this online environment. It starts, well, roughly in the real world, but in the context of this COVID era, it moved there. And they're simultaneously learning to navigate this online platform, but they engage with a real world material science case study, and they step-by-step in a scaffolded manner, taken through analyzing that, but so as to anchor the theoretical principle, hence the work-directed theoretical learning. And that's just one example, and I'm sure there are many. Now, when we move to project-based learning, for example, here's another colleague who was part of the ESCAPE project, transport engineering, where you can see we now wave up and down that semantic wave. So each of these types, each of these modalities is a wave in itself, but they form part of a larger overarching wave. And here, students have to work with 2D to 3D conversion technologies. They have to work with the fundamental principles of traffic flow. They go out as a group into the real world. They find a real site, having to learn how to orchestrate that amongst themselves and each other. and they have to design a solution for a particular traffic flow problem. Now, this is a fantastic example, but think about it. It's still relatively idealized and controlled. It still isn't this. When we move into this space, which on that left-hand graphic is this beautiful little idealized, very neat graph of this is the smart world. This is the reality of what that world looks like in my context. Those are all, most of those are photos from my own students and my own groups of people out in the industries with whom I've worked over the years. That reality is so complex. And Robbie Pott later this afternoon, you'll see a bit in session 28, where we're going to be looking at building flexible graduates. We'll refer to a study that they've undertaken, an alumni study, where students tell us that 80% of their time is spent working with other people in meetings, having to organize things with other people. And it is so missing in the curriculum. However, the point is that in moving towards that space, I think, so for this one strategy is if we view this as a journey towards being able to cope in that space, there are work-facing strategies that we can employ, but that all fulfill a different function. So now we'd like to hear from you. Now we have three options. I can see you because I am online and I will go and find you in a moment. Are you using any of these modalities? People here in this hybrid venue with me as well. People in the online space. So Liesl, keep an eye on that. I'll also open up if there are. But switch on your camera, talk to us. The engineers can share things. It's important also, what challenges are you facing in enabling this employability development? So you can either put comments in the chat box, free to put up your hand and talk online, please. But I've also added, Liesl has put the bit.ly, the short URL into the chat box. I can't share that screen with you because we have a very different system here. So I have no control. Tells you about the organization. But I can take a look. I can see the live document itself. So if some of you want to go to that document, I've put in a little table that says which modality, feel free to add or feel free to chat. Liesl, anybody online wanting to comment? Anybody wanting to share anything? If you don't share anything, I'm going to pick on you. Nicholas West, you are in the audience, you're online. Would you like to share anything? I can go back if you'd like to show you the semantic wave. Go for it. Yes, Liesl.
We have a dichotomy. The alumni say they need more professional skill development, example, what some call soft skills, while employers still tell us technical is imperative. Robbie, I don't know if you want to talk to that.
Robbie,
I'm sure. Yeah, I mean, Karin, you know, we've had this discussion often. We know from our alumni that they do need more development of different modalities, things that we don't focus on in the curriculum. I mean, they're there, but we're not focusing on them, we're not specifically training on them. But whenever we speak to employers, when we have the industry come around and give us input on what we should be doing, they always are terrified that we're going to take away technical content and technical know-how and replace it with what I'm calling professional skills, which some people call soft skills. And I think there's not actually a dichotomy there. It's not one or the other. It should be and, but there is a limited time. And yeah, maybe your thoughts on that, Karin.
Robbie, I think that's a very important point that you're making here. And even in our University of Technology sector, and I think because of projects like those ESCAPE projects, Chris, and those other kinds of projects, the field as a whole in the professions has been battling with this overburdened, this heavy curriculum, and this sense that, and I'm going to put my head on a block here and suggest that over the last 20 years, but particularly the last 10 years, we have not necessarily understood what it means to develop technical expertise. I think in the earlier days, we thought, right, that means I must give you the technology and the tool, and you must practice it in our education space so that you're ready for that workspace because of the different levels of the tertiary or because of the different education levels. Europe, I'd love the UK to come in here as well for, you have such a strong apprenticeship model and you have a different relationship with your industries, very much like the healthcare sector in South Africa. In health sciences, there's also a different relationship with the people who employ you. Those students get that clinical practice as clinicians, as per Cecilia's paper earlier, where that's going to happen. And there is stuff that'll happen by osmosis. But in our space, we know and have known for 10 years already, we cannot add every one of these technologies in there. And as Robbie's study shows, those contexts, when you move down that semantic wave onto that contextual line in terms of the complexity of the world of work, are so different and varied. So we need to be taking a different approach, which I think that we are starting to do, and you will see this later this afternoon in session 27 and 28, is how do we lift that up off that ground, out of the smarties into the concepts, okay? And to anchor that and ways of working with those concepts that stretch and make our graduates more flexible. Yeah, Robbie, I don't know if that's, I mean, it's part of a conversation. You're welcome to come in again. But I think we need to start being brave to start cutting stuff out of the curriculum. I see people screaming already. I do notice, so online, thank you very much on the first task. So in the health sciences, I'm not sure who this is, but work-directed theoretical learning very much happens in classroom-based teaching, and I'm assuming that's examples from work, and here is the theory, and here's the stuff we do in the classroom. So also case problem-based learning in the health science education. Problem-based learning takes a form of case studies to differentiate between, oh, that's very nice, normal and abnormal disease, for example. Okay, in their project-based learning, and this is like Liesl Hudson, our colleagues, virtual radiation physics learning environment. So there you've got the simulated environment. And I believe that in engineering, you're going to see the same, very much the same in mechatronics and in some of the, obviously, computer sciences and in the ICT space, where those simulated environments, our electrical, electronic here as well, that's been easy to move into building some simulated circuits, for example. Okay, and also workplace learning, varying from 360 hours to, okay, half theory, half industry over 4 years. That's very interesting. Okay, anyone else in the chat want to share a particular modality about moving towards the world of work in these? Liesl, anyone there? No? Okay, fantastic. We can go back to the slides. If I can find them. Right. Okay. So I think one of the big questions that we're seeing is there are so many websites and blogs and whatever giving us the answer, paths to 21st century success, and all of those wonderful attributes that we want our students to have. Now, as you will maybe have seen from the few inputs that we gave and just Robbie and my brief discussion here, it took us straight to, but what's in the curriculum? Okay, what do we do in that space? So in order to develop these attributes in those graduates, let's move to our next tool. So you've seen quite a lot. And again, as semantics has helped in pedagogy with that shift from theory to practice, up and down, building cumulatively, the specialization plane has been fundamental in helping us to just see. One of the participants in the earlier session was talking about, just before we started, was saying, in LCT, as you know, once you've seen, you cannot unsee. So this tool was used in the context of our larger ESCEP project. And as part of that project, I worked with the Department of Industrial and Systems Engineering at CPUT. And we used all of these tools extensively over the period of a year. These were monthly, full day and half day workshops with the entire team. It was such a privilege to be able to work with all these people. And this was a fundamental tool with which we had to start. So for those who don't know, and there are many people that I've seen in our LCT 3.5 around the world who don't necessarily, they're not necessarily that familiar with all of them. So the specialization dimension is essentially about helping to differentiate between what it is that specializes someone or something. In other words, what gives a practice or a practitioner its legitimacy. You know, is it a kind of knowledge? Is it a kind of disposition? Is it a combination of both? Is it neither? I want to point out that neither quadrant is not a bad quadrant. So I think it's important for newcomers to the LCT space to understand that what's so useful about the Cartesian plane here is that each of the quadrants needs to be seen in relation to the other and the axes, but that what happens in the minus quadrants just points us to something else. Something else is happening. Okay, so that's just a heads up methodologically. Now, from the literature, we've seen that all STEM fields keep being listed as being more knowledge focused. You know, people will say STEM is more knowledge focused. Art, for example, might be more knower focused. Some fields don't actually know what they are. And we all know some of those fields. The reality is that the professions require a combination of kinds of knowledge and the development of kinds of dispositions or attributes that are more about being a certain kind of knower than just having that kind of knowledge. Now, all this stuff and these complaints that we had about industry saying they don't have all the soft skills, okay? They can't manage meetings, they can't do all of that. That points us to that bottom right quadrant in terms of STEM maybe, but particularly in engineering. Now, with this very group and in subsequent other studies, we started with the specialization plane and we looked at what were then called the engineering exit level outcomes and are now called graduate attributes. And we looked at 10 fundamental ones that we listed. And through negotiation and discussion, it was decided that each of these outcomes had a particular dominant orientation. It did not mean it only sat there, but it meant that its dominant orientation was in a particular quadrant. It was relied on a particular kind of knowledge or a particular kind of knowing or a particular combination of both of these. So that first experience with this tool was such an eye-opener because when they first did this exercise, they had totally different interpretations of what that meant. And that just tells us, perhaps the earlier comment that we made where Robbie and I were talking about what the employers say and what the students say, the recent graduates who are now newly employed say, perhaps it's precisely that, different perceptions of what that means. We all know that every single knowledge practice is actually a combination to varying degrees of a kind of knowledge and a kind of disposition. It really is. Okay, so there are varying degrees of this, but to see that, you can use this tool to see that in the first place. So what does need knowery elements? Now, the interesting thing there is that study linked very well to a study that we did looking at all of the engineering education research literature in South Africa over a 4-year period, the 4 SASE conferences. And the interesting thing was, engineering is classified as a knowledge code. It sits as in the knowledge space. Everybody will tell you that knowledge and technical skills related to knowledge are more important. All the literature is about knowers and a whole lot of other stuff. That relativist stuff there was about throughput and quantification and statistics. But the literature about engineering education over that period all happened to be about knowers. So if we take this one step further and we go, okay, so let's agree that there's a lot of knowery stuff actually that we want from our students. If we look at those outcomes and we know there's knowery stuff, particularly in our case, that whole communication, impact on society, management, independent learning, ethics and professionalism, all depend or are anchored in some way on a kind of disposition. Then, to connect back to our first strategy, things like that project-based learning experience. In other words, in preparing them for employability, there are strategies to build those things that don't take away from anchoring theoretical concepts, that don't take away from using the tools and techniques. You know, instead of sitting on your own, grappling with a threshold concept and practicing it. Well, okay, hang on, stretch it a little bit, go and find that concept in the real world, link it back to your book, maybe work with a partner. How much harder does that become? It's adding. And so that's the point here. Looking at your curriculum, identifying what needs what, and then seeing how do we combine those to build that over time. So round 2, your turn for input here. What I'd like to hear from you is, okay, what is your curriculum focus? What is it explicitly? I'm assuming that in the health sciences, we're sitting with a lot of health sciences and engineering related people in front of me in this wonderful hybrid space. And here, I mean, I know that if I look at your curriculum, it's going to all look like knowledge. It's all the knowledge stuff. But is there stuff that's changed over time? Again, please, you can go to the short URL, the bit.ly code to the worksheet, add an example, be fantastic if you can. What is knowledge in your curriculum? What's knower in your curriculum? Or how do you integrate knower dispositions into your curriculum? Anybody would like to speak up? Or yes?
Your presentation, task 2, curriculum focus.
Yes,
Okay.
task 2.
Just
Thank you.
in the,
It's task 2 if they'd like to add anything. If anyone wants to add anything as we go along, we are not using this for further research. So, and you are totally anonymous. Yes. Penelope.
So I was just wanting to answer quickly your
Yes.
question. And in our curriculum, we actually have a subject, becoming a radiographer, kind of becoming a health professional. We actually, so, and that does have knowledge stuff in it. I mean, it is, but it also quite knowery. So I just put that out there.
Yes.
And it's quite a nice bridge. And that came because in our old curriculum, I think we called it patient management or something like that. And so we had a much more kind of heady thing approach to it. And interesting, when we went to our degree, we realized we needed the side of psychology and sociologies and the philosophies of health, and we needed knowledge, but a different knowledge
Yes.
base to health.
Yes.
So that's a one quickly. And then I just think in that, I mean, some light that went on for me is that LCT is a really nice tool to scaffold how we develop this in our students. And I haven't been through that exercise in my head, but that just came on for me now. If we actually look at our curriculum, we'll be able to see the pitfalls of why we're not getting where we're hoping to get to, and how we could do it better. Yeah.
So I think that's a really interesting thing, because when we discussed and you asked me to do this kind of more interactive workshop session as part of this, and I thought back to my roots here in that whole work integrated learning space, I hauled out because that's a fantastic guide. I know there were lots of ups and downs about it. And I initially was going to go, here are examples. And when I read them with today's lens, as someone previously said, with today's LCT lens, I read this document, which is over a decade old. It was so clear to me that the different modalities can be used coherently together to effect exactly the end goal that we're talking about, enabling graduates to be more employable. And that's what makes LCT so powerful. It's precisely that. And that's when it struck me that work directed, you could organize them on the semantic wave. And can you imagine in a curriculum, you could start in reverse. You could start in the workplace and have a soft project, not hectic theory yet, then move to, in other words, you could zoom in a different way, in a different context. I think our problem maybe is, well, that's how a lot of the Europeans do it. They actually start there and they build towards the conceptual over time in a different journey versus ours, which starts with the theory and the very tight bounded. I'm just saying, I had the same aha moment just thinking about this task. Are there any other examples? Liesel, anybody in the chat?
I'm in the
You're in the document, sorry.
excuse me. So they're completing the
Lee
task.
wants to chat. Oh, I can see Lee. Unless Lee, your mic is
Yes.
off.
She can go ahead.
Okay, can you hear me now? Thanks. So what I found so interesting, Karin, is the preparation of work-based learning for engineers compared to what is really necessary for teachers. Because for teachers, they've already been in the classroom for 12, 15 years. And because it's such a familiar context, they think that it's a familiar practice. And so, you know, some of our thinking is about how to take them away from that context for a while, give them those theoretical tools, and then work our way back with a new lens, a new gaze. So that's quite, it's just so interesting to see, you know, the different practices and the implications and how we're working differently, but we're both working with semantic waves, but in different directions and perhaps for different reasons.
But what you've just said, Lee, has just jogged my memory, because one of my first experiences here at CPUT in the University of Technology sector was that immediate observation that our students who had come from a background, as I myself had had, of a father and a grandfather and a mother. My mother did all the electrical work at in the house. We had a well set up workshop. We worked with tools. So, you know, the kids who came from farms, who worked with implements, who worked in those spaces or those workshops, had a totally different orientation. So it's a little bit like what Lee's saying, that wave starts on the ground in the real world. But sometimes, and in South Africa, we have an expression, a boer maak 'n plan, which is a farmer makes a plan. Okay. But that means that trial and erroring that happens is a little bit, I think, what Lee, you're referring to as your teachers, their own experience in the classroom might bound. In other words, sets parameters around them, confines, exactly, restricts. So it's some kind of restricted code a little bit, and your job is to break them out of that. In many cases in engineering. Yeah.
Sorry, but there's also, you know, when we're sitting with a situation where 80% of the schools in South Africa are not as working as well as they should be. We don't want to perpetuate practice. And if we don't bring in that theoretical lens, they simply then default to the prevailing practices from wherever they've come from. And so if we're wanting to use it, the work-based learning preparation as you know, to disrupt and also to open up new possibilities. You know, Carl was talking about a mindset of possibilities, but those new possibilities of how things could be. The distanciation is so important, but to bring them back all the time.
Yeah. So the interesting thing, and the last thing I'm going to say just about the strategy, in other words, about using the specialization plane to differentiate and see the different elements of your curriculum, and then using the semantic wave or plane to move between those different knowledge knower elements and in a cumulative fashion. Yes, Chris.
It's a comment more than a question. But it relates to what Lee said about the, you know, disrupting and doing things differently, because, you know, a lot of engineering practices, for example, are no longer sustainable. And we do need to, what you didn't add onto those graduate attributes was a whole pile of sustainable goals, which is more issues for engineers to address. A lot of the burden of solving these problems are going to fall on the shoulders of engineers. And I think that the technical disciplines like engineering tend to vastly underestimate the knower attributes and what it takes to achieve those attributes. So they're easy to name, and no one would dispute that they are desirable. Of course, you want engineers who are aware of the environment and the impact of their practices, but you ask the question, what does it take? And I don't think they have a clue, particularly not what it takes to attain a graduate attribute in a NOAS. When you're coming from a knowledge quadrant, an ER plus SR minus quadrant, and the foregrounding has been the scientific engineering knowledge, what it actually takes to achieve. So people in the humanities and social sciences wouldn't be so free and easy with piling more and more things into the NOAA quadrant, because they know what it takes. And the Engineering Council of South Africa will just continue piling things into that knowledge, into the NOAA quadrant, because these things are desirable, aren't they? But I think the issue needs to be looked at rather differently, not what, you know, and to shift from an individual perspective to a more systemic level approach, because I think what it takes is actually to learn how to collaborate and to respect other people's knowledge, because you can't if you're trained in classic construction technology, you don't know how to build a green building. You don't, and so building a green building is perhaps in the elite quadrant.
I'll tell you where it is.
And you just don't know, but you need to have kind of respect for other people and what they can offer to the engineering discipline, and how you can collaborate with them to construct a green building.
So we're going to look at that now. That's strategy number 3. Thank you, Chris. Okay, we can go back to the slides, you guys. Right. Yes.
Responses on the live document.
Oh, did that? Oh,
There's
okay.
a BSc Physics and an English Studies.
Okay. Fantastic. And an example, and you want to give me a summary in brief?
Do you want me to read it?
Yes.
BSc Physics say the current curriculum focus is very knowledge focused. The challenge is to prepare students for the unknown career, essentially wanting to develop scientific problem solving skills, building elite graduates, problem-based learning in undergraduate, project-based learning in honors and group work. And in the comment section, little contact between industry and academics usually, but someone from industry who employs our students has said he needs a few BSc graduated workers, but he also needs others who have just had first or second year, but have shown that they can learn independently.
That's very important.
And then English Studies, current curriculum focus is very NOAA. With challenge teaching a NOAA code via distance education with massive student numbers. How to build the elite graduate, learning the academic literacies through continued writing and feedback. And in the comments, application to world of work is very unclear to students. A last one is university-wide revising graduate attributes. And the person is still busy typing in the current curriculum focus. So I will go to the challenge, the strategy, integrating effective ideation, innovation mindsets, and adaptive practices into career development. How to build an elite graduate. The aim is to provide the attributes that have been assessed throughout the program, but we want the graduate or knower to set their own graduate attributes.
Interesting.
The current curriculum focus is knowledge is the graduate attribute allocated most frequently.
Yes. Okay, fantastic. Now we're going to go on to that complexity, exactly what Chris was talking about, because it takes us to strategy number 3. So if we zoom in, so you will see that everything we talk about, all of these fields, the health sciences, engineering, the STEM, all of these, we know that there's such a strong knowledge, nobody's disputing that knowledge base, but it's that application of that knowledge in particular contexts. And that's the whole point of LCT. It helped us to actually see why the hell is this all going wrong? These people, or why is it going right? What makes it work? What makes it legitimate, etc. in a particular context? So now if we zoom into that, then we get my wonderful favorite epistemic plane. We're now zooming into that knowledge quadrant, okay? And I'm not going to spend much time on this at all. Suffice it to say that when we zoom into the knowledge quadrant, we're interested in what and how, okay? When we zoom into the knower quadrant, we're interested in who and how. Now we're looking at what and how. What is this knowledge or knowledge and its associated practice element? And how do we approach it? And the vertical axis is simply about how bounded a phenomenon is. We talk about it having stronger or weaker ontic relations. Stronger ontic relations is simply something uncontested. It's something that doesn't matter how you approach it. It is what it is. Concepts like gravity, a lot of the concepts, the laws of motion, a lot of those things have what you call strong ontic relations, okay? We're not worried about how we approach it now. Oh, something with weaker ontic relations, there's something like justice. It needs context. It might be ambiguous. It might be misunderstood. These are concepts that are weakly bounded. We need to bind them in a way. The horizontal axis is about how we approach whatever the phenomenon is that we've got in question, okay? Either with a strict, standardized, strong, fixed approach on the right-hand side, or towards the left-hand side with more open-ended, or there are multiple ways. So that gives us, as we know in LCT, 4 quadrants, where your top right is here is a strongly bounded phenomenon, and the way in which we approach it is standardized. And all of our curricula in the room that I'm in now, in the STEM space, sit up there, okay? The fundamentals of electromagnetism, of fluid mechanics, of strength of materials, of radiation physics, all of that stuff sits up there. The world has agreed already on the how. The problem is when we pull it into the world on the left-hand side, bottom left quadrant, where there are knowers, or top left-hand quadrant, where there is a situation that's going to dictate how you use something, where that phenomenon is still applied. But it's how you're going to address it changes because the context is different and each context requires a different kind of approach. Okay, the bottom right quadrant is simply the method itself matters more than the phenomenon that you're addressing. We're going to be talking all about this in session 28 today, so I'm not going to spend time on this now. What we do know from tons of research is that the point is to be able to move around that plane, to be able to move from fundamental principles to, or from procedures to different situations that need you to apply a different, to choose something different, taking into account precisely what you were talking about earlier, Chris, in terms of the different knowers in these spaces, the different people with different attributes. That plane is a perfect example of the space in which we can build these elite graduates we're talking about. And if you equate those movements, those examples of a different context with the idealized semantic wave, that is cumulative learning, but that code shifting ability is what we need to be able to do. And what we also know is we're stuck on the right because of, we're not stuck on the right. Our mandate is on the right-hand side. We must be careful to not bash ourselves too much. Our mandate, the education space, is to anchor, to develop purist insight, to develop doctrinal insight, to open up into that space of potential situational and knower insights, okay? But there's too much of a strict divide between what it is we're doing on the right-hand side of that plane and all those world of work people screaming for flexibility, open-ended problem solving, situational awareness, knower awareness, all the stuff that they have to do in that space. Now, one example, I'm not going to spend time on this because you're going to see it again in session 28. Let me just advertise some more, session 28. Okay, from my colleague Robbie Pott. But here is an example of you cannot just throw one project at students at a time. It's that same careful scaffolded iteration. It's that movement, it's iterative. Robbie's got a fantastic paper out there from 2 years ago where he looked at our very traditional Stellenbosch University environment, where the lecturers are fundamentally there, but they can anchor themselves in the situational, that work-directed theoretical learning, pull from there, pulling it through into the tutorials and the practical spaces. But those practicals can also move up towards the situational, open it up a little, different kinds of practicals. Not every student has to do exactly the same prac in a course. There's no reason why they can't do, different groups can do different pracs, but if you pair share them or give them group opportunities to feedback and share that, you're already exposing them to situational insight. The same principle in a different way. So that is just a demonstration of one of the benefits of using the epistemic plane is now to move students around the space from fixed to open-ended, from the textbook to the world of work, from their own lives into the bigger sustainable development goal challenges. And that has to be an iterative process. I mean, some of those examples, these are all from our contexts, are, we have huge constraints again in the global south, resource space, massification, numbers, all of those things. So as much as things like site visits are fantastic, we at this institution, CPUT, know how complicated that is. You cannot take 150 or 350 students to one site to visit, but we need to be, this is the space of possibles. Here's where we can start using our plane to see what's missing in our curriculum and in our pedagogy, and then coming up, you can bring industry to your students. Today, so much more is possible. So much is possible. You can bring your alumni to students. I don't want to give you all the answers. I just wanted to say that this is about building code shifting graduates, those who are able to recognize what they need where, because a code shifting graduate equates to all that stuff we saw before about adaptability, flexibility, these brilliant supermen and women that the world expects us to deliver, it's a terrible technicist term I've just used, but you know what I'm saying, to help to facilitate the development of, how do we build that flexibility? So what I've tried to show you, and I'm going to ask you for feedback now in a moment, is just here are tools that when working in concert with each other, you can begin to flesh out. And what I particularly like from the presentations earlier today is you guys in the health sciences and in the other engineering paper, you've got beautiful translation devices that can really help you at a next level, zoom in them to each of those about then what do we mean by a knowary kind of attribute, 5 different levels that imply different things in the professional space. So that's what the point of this is. So talk to me about, in words of wisdom, any examples? Yes, Liesl.
But I don't want to deter from this point. There is a question. Can I keep it for later?
Yes, you can.
After this, okay.
You can. Okay, no, is it Rita Knutz's question?
Yeah.
I'm going, no, I'll deal with it. Okay, because we are into the last 5 minutes of this before the next panel, but because we're in the same space, we can do this. So Rita's asked a very important question, which those of you online can see, but those of you here can't. Does moving around the epistemic plane in your teaching automatically entail shifting up and down on the semantic profile? This is a very interesting thing. What I was going to say is I think you need to imagine a semantic profile in each quadrant, firstly, because you can develop purest insight by also moving relatively between a different level of abstraction to a different level of contextualization or context specificity within just developing purest insight. You could do the same in each of those quadrants. So I think it's more complicated than just equating one tool with another, because we've tried to capture that same code shifting on the epistemic plane using the semantic plane. And that's also different because that's degrees of complexity and condensation of meaning and degrees of context independence. But if you take them, you could use them all together in different ways to point out different things to refine what you need. Rita, I hope that answered your question. Right. Anyone else with an example of how you build this flexibility in? Anyone want to speak up? I can't see. Kind of limited there. It's on task 3 if you'd like to go there. We are.
It's on slide 10.
Sorry, slide 10, yes. Slide 10. There are people who are writing here. That's fantastic. Oh, fantastic. It's Karin's own example. Hello. Right. Anyone in the room here? Examples of building that flexibility, health sciences.
I was just thinking now is it the time for our students in health sciences to get some education theory? And so that they learn about learning. I know we talk about adding yet another thing, but I come back to this, we talk about give a man a fish and you feed him for a day and teach him to fish. And we say this so glibly as if we're doing it. And probably we're not until we teach them how to, about learning. So, I mean, that's enough.
No, I think you've said something really important because that's the whole point about Lee's work, Lee Ruzniak's work, in terms of, okay, right, they are going to be teachers, so they need to learn about teaching and pedagogy, so they get the tools. But in our Stellenbosch context, I've got a colleague in process engineering who has taught them about the epistemic plane and what they need to do. And we've got people experimenting with all the UK and all the writing. Sharon Clarence and Steve Kirk's, they teach students about the wave so that and I think that you've got a point there. I think we need to teach our students about the findings of code shifting graduates being successful graduates in the professions and what that means. And that we then take those quadrants and we highlight for them in your practices. These are the different parts of your curriculum and your learning experience. This is what we're building, because together, iteratively and in different patterns, this leads to an employable graduate. And my timing is perfect. Yes.
Before we go, there's one comment, and Anonymous Wolf is still typing.
Thank you, Anonymous Wolf.
Context is physics and the strategy is practicals. Even measuring something at home when large classes do not allow face-to-face practice. Challenge is get the students away from wanting to get the correct answer towards critical evaluation of what they did. And the person is still typing in the other comments.
Yes. If we can just put the slides back on again, I want to just say that for posterity and record, just that I worry. I mean, we use all these LCT tools all the time. So Carl, you're there. I'm just saying. All right, you can cut back. Thank you so much. You guys, thank you for a fantastic interactive experience here at CPUT. And I will see you all online in just a while. I'm going to drive and watch you online while I'm now driving. I'll watch you, and then I'm going to get back onto the other side to set up for session 26, 27, 28. Thank you so much.